Lesson 50 is finding inverses of relations and functions. Okay, if we were normally going to graph these ordered pairs, as you see here, we have an x and a y, so we've got 3 and 8. So we'd go over 3 and up 8. We'd go over 2 and up 4. And then we'd go over 7 and up 11, so about there. All right, now one way that we can find the inverse of this relation is we can flip all of these points, or if they're lines also, over the line y equals x. Now if we're looking at this point here, this is the point 2, 4. Alright, if you look at this, this is exactly 1 square away above and to the left of the line, so it'd be 1 below and to the right of the line, so it'd be this point. If you look at this, that's 1, 2, 3, 4, 1, 2, so this point is 4, 2. Alright, if we look at this point up here, this is at the point 3, 8. Well, this one would be a little bit harder, but 1, 2 and a half, 1 and a half, 2 and a half. Where's that point at? We're over 8 and up 3. So as you can tell from both of those 2 points, then all we do to find each one of these is we flip the x and the y. So this last one is 7, 11. Our inverse of that would be 11, 7. So our 3 inverses would be 11, 7, 4, 2, and 8, 3. You can always just switch the x and the y, and there's your inverse. Now that also works on graphs. So, or straight lines, curved lines, whatever it is. Alright, this one says find an equation for the inverse of y equals 8x plus 14. Well, what we could do is we could graph this thing out. We can make each box worth 2. So then we would go up 7, 5, 6, 7, put a point, and then our slope would be 8. Well, I'm going to come down 8 and over 1, and then I'm going to draw that line in there. Now, to make an inverse of that, once again, it's going to go through the line y equals x, which I have here in red. But, as I just said, all of these points, we can just switch the x and the y. Alright, so this point up here at 0, 7, we could come over here 7. And that one would be right there. This one is just already on the line, so we can just use that. And there's our equation of our inverse. Now if you look at this part of the line does flip over the y equals x line to become this part of the purple line. This part of the blue line you can see flips over the red to become this purple, so it does flip. Now the problem with that line is, how do we find the equation? Well, technically we don't even have to graph this to find out what the equation is. We could flip x and y down here for our points. We can also do that in the equation. So we would have x equals 8y plus 14. And you can do that as long as you solve this for y. So we'd have to subtract 14 and divide by 8. So y equals 1/8 x minus 14 over 8, or 7 over 4. And that would be the equation of that line there. Next one, we can do the same thing for this. Find an equation for the inverse of y equals 2/7 x cubed plus 8. Well, to find the equation of it, we're doing the same thing. Alright, we would switch the x and the y. So x equals 2/7 y cubed plus 8. So we would have to solve for y here, so we'd have to subtract 8. Then normally we would divide by 2/7, or we can multiply by 7 over 2. So then this would become 7/2 x minus 7 times 8 is 56 divided by 2 is 28 equals y cubed. How do you get rid of that cube? You take the cubed root. And our equation is y equals the cubed root of 7/2 x minus 28. Then it says, using the vertical and horizontal line test to determine whether each relation is a function. Alright, well, I don't know how to graph this, but I do know that I can graph this thing, and I can make an XY chart, and this won't be too bad to do an XY chart. If I throw a 0 in for x, I get an 8 for y, a 1 in for x, I get an 8 2/7, a 2 would be, let's see, 2 cubed is 8, times 2/7 is 16/7, which is 2 2/7, so that would, plus 8 would be 10 2/7. -1 would be 7 5/7, and you can do this by just plugging these in here for x and solving for y. So it can just be a calculator exercise then. So this would be 5 5/7. Alright, so the original would look something like this. Now what we did know up front was that this was a cube, so it's either going to start high and then low, or start low and then high. So there's our 5 points. If we connect these, this is going to be approximately like that. Now if we look at this and we use our vertical line test, is that a function? Yes, that's a function. Now, how are we going to find the inverse? Well, to find the inverse before, we just switched the x and the y, so let's do that again. And then we graph out all of those points. So approximately there. We draw the line in there. Okay, now if you look really carefully, you can see that this does do a pretty good job, even with my drawing skills, of flipping over that line there. And it's even going to intersect, I think it intersects right here, if I remember right. So my graph here is a little bit off, but I think it intersects there. Alright, and then, well, is this one a function? Well, we can look at this. Yeah, it does pass the vertical line test, so this is a function also. Alright, moving on, find the inverse of y equals 3x squared minus 9. Alright, well, we can switch x and y. So x equals 3 y squared minus 9, and then solve for y. So x plus 9 equals 3y squared, divide by 3, 1/3 x plus 3 equals y squared, and then we've got to take the square root. So y equals the square root of 1/3 x plus 3. Now remember, whenever you're taking a square root or a fourth root, we're going to have two answers, so we've got to put a plus or minus in there. But then it says, restrict the domain so that the inverse is a function. Alright, what does that mean? Well, let's look at this equation first. Alright, if I were to graph that, my vertex would be at 0, 9, or 0, -9, and then I'd be here, and here, and that would be my graph of this. Now, if I were to graph this, remember, I can just switch those points that I have on my black line here to find the inverse. So this 0, -9 turns into a -9, 0. This point, 1, 2, 3, right there, and right there. So our inverse is going to look something like what I have here for a blue line. Now, it says restrict the domain so that the inverse is a function. Well, if you look at my blue line here, That's not a function, it doesn't pass the vertical line test. Alright, so we need to restrict the domain on the original function so that our inverse is also a function. Well, most of the time what the book does is, if we get rid of half of the graph, that would get rid of half the graph also, and that would get rid of the bottom part here. And then my blue line is a function. So you could say, well, I'm going to restrict the original as x greater than or equal to 0, because then I would get this blue line. The other thing that you could do is, let me redraw this quick. And so there I'm back to the original. If I got rid of this part, I would also get rid of that part. So this is one of the very, very strange ones where you just gotta pick x is greater than or equal to 0 or less than or equal to 0, and it is going to be the right answer. Alright, but it is always trying to get rid of half of that parabola so that the inverse is a function. Alright, next one. If you read through this, distance traveled by a boat over a period of time was recorded as that equation, where d is distance in miles and t is time. How long did the boat travel if d is 519? Well, any normal person would throw the 519 in for d and solve for t. So why wouldn't you just continue to do that? Alright, we'd subtract 7, so 512 equals 8t cubed, divided by 8, we get 64 equals t cubed, take the cubed root, and t has to equal 4, and then remember your label on it, so 4 hours. Alright, so continue to do what you already know with this one. This is just a word problem. You could switch the d and the t and solve for the variable that you're looking for and all that stuff. You do get to the same answer. You don't have to do it that way though. Alright, so any questions, please let me know.